Today we are going to talk about components of a vector. Before we do that, I want to explain to you what it means to multiply a vector by a number. Let's start with a vector A, and I'm going to add A plus A. That is, I'm going to add the vector A to itself. So let's see how we do that. So as before, we first take a copy of that vector and then let's move it and place it head to tail like so. When we do that, you can see that the resultant is going to be this, starting at the tail of the first one, ending at the tip of the second one. So it's going to be a vector twice as long, pointing in the same direction. A plus A, we want to call it 2A. 2A is a vector twice as long, pointing in the same direction as A. Now you can imagine what 3A will be. A plus A plus A. It's going to be a vector 3 times as long, pointing in the same direction. So when you multiply a vector by a positive number, you're going to get a vector in the same direction. Okay, now this is 3A. What do you suppose minus 3A is? Minus 3A is going to be a vector opposite to this one of the same length. This vector is going to be minus 3A, and you can see right away that multiplying a vector by a negative number is going to give me a vector in the exact opposite direction. If the negative number is minus 3, then it's going to be 3 times as long as A. If it's minus 3.5, it'll be 3.5 times as long as A, but pointing in the opposite direction. So this is what it means to multiply a vector by a number. Suppose now we have a vector of length 1 in some units. If I'm talking about displacement in SI units, it's 1 meter. If I'm talking about velocity, it's 1 meter per second. If I'm talking about acceleration, it is 1 meter per second squared. This is a unit vector, and let's give it a name. Let's call this unit vector V, and normally I would put an arrow on top to indicate that it's a vector, but now we happen to know that its length is 1. So we put a cap. When you see a hat or a cap on top of a letter, you know that it represents a unit vector. Now let's ask the question, what is 2V? Now you can see the answer to that. Immediately the answer is going to be a vector twice as long, and it's going to point in the same direction. And what is the length of 2V? 2. Because V has a length 1, this has twice the length, so 2V has the length, that is its magnitude, is going to be 2. And likewise, we can talk about minus 2V. What would minus 2V be? Let me write that down. Minus 2V cap. I'll start calling it cap in future. Minus 2V cap is going to be a vector in the opposite direction as V cap and has a length 2. So when we start expressing vectors in terms of unit vectors, we can just look at the vector or the number in front of it. Its magnitude will tell us the length of the vector. Now let us introduce two special vectors. I have the x-axis and the y-axis. I have now introduced a coordinate system. And let's introduce first a vector pointing in the positive x direction of length 1. A unit vector pointing in the positive x direction. Let's give this vector a name. It's going to be I cap. Cap because it's length 1. Similarly, I'm going to introduce a vector which points in the positive y direction, also of length 1. So a unit vector pointing in the positive y direction, let's give it a name. We'll call it J cap. Now we will see that any vector in the plane pointing in any direction having any magnitude can be represented in terms of these two vectors I cap and j cap. So we have this vector v, and let us see how we can write this in terms of I cap and j cap. We can go from the tail of the vector to the tip by first moving in the positive x direction by 3 units. So we got this vector, and then moving in the positive y direction we get this vector. Now what is this vector? This vector is 3i cap. Why? Because I cap is a unit vector pointing in the positive x direction, unit vector, and this is 3 units long, so this is 3i cap. And this is 4j cap, 1, 2, 3, 4, 4j cap, and what we have here is vector addition. This vector plus this vector is our vector v. The numbers 3 and 4 are called the x component and the y component of the vector. The x component of the vector is not 3i, it is 3. And the y component of the vector is 4. This is 3 units long and this is 4 units long. By Pythagoras theorem, the length of vector v is 5. We can find the magnitude of the vector by squaring the x component. We'll call it vx, that is 3. 3 is the x component squared, plus vy squared, that is the y component squared. Let's go for a different vector now. Let me draw this vector. Take a look at this vector. It goes from the origin to this point. And what is this point? X coordinate is minus 6 and y coordinate is 2. So from the origin, we go to minus 6, 2. Can I write this vector in terms of I cap and j cap? Remember, I cap is a unit vector pointing in that direction, and j cap is a unit vector pointing in that direction. So to that end, let's drop perpendiculars. So I drop this perpendicular here onto the x-axis and draw this line here. So you can see that our vector, what shall we call it? We'll call it A. A can be thought of as this vector to the left plus that vector going up. Now what is this vector going to the left? Negative 6 I cap. Remember, its length is 6. It points in the direction opposite to I cap. I cap is a unit vector. So the minus tells me it's opposite to I cap. This vector going to the left is minus 6 I cap plus that one is 2j cap. This is our vector A. Now remember, once you've expressed a vector in terms of its components, in terms of I cap and j cap, which are unit vectors, and 6, what is the x component of A? Minus 6. And what is the y component of A? 2. Once you've expressed it in terms of minus 6 and 2, you can't simplify this further. Don't try to add minus 6 to 2. They are in different directions. This is in the negative I cap direction, minus 6i, and 2j is in the positive y direction. This is a vector addition symbol. This is a vector addition symbol. So don't try to simplify it. Of course, in some schools, you will be asked to find the magnitude of A. To find the magnitude of A, you can certainly use the Pythagoras theorem. That's going to be 6 squared plus 2 squared to the power of half. Square root of 6 squared plus 2 squared. One more example. From here, I'm going to draw a vector down to there. Right? You can see right away that this is going to be this pointing down plus this pointing to the left. And by now you should be able to tell this is minus 4j cap and minus 1 minus 2 minus 2 I cap. Usually we put the I cap first and then the j cap next. This is our vector which we have drawn. So you see that any vector in the plane can be written in terms of I cap and j cap. And this particular vector that I've drawn, its x component is minus 2 and its y component is minus 4. So we can write this as, if this vector is called B, we'll call it bx I cap plus by j cap, and bx is negative 2 and by is negative 4. And what about the magnitude of B? It's going to be square root of 2 squared plus 4 squared by Pythagoras theorem. And furthermore, you can also find the angle. For example, let's go to our original vector here. I want to find the angle theta, let's say. Now this is 3i cap plus 4j cap. So let's write that down again. V is equal to 3i cap plus 4j cap, and the magnitude of v we found by Pythagoras theorem is 5. So if I call this angle theta, its opposite side is Vy, its adjacent side is Vx, and that is equal to tan theta. Tan inverse 4 by 3 is the angle theta. So you can find the magnitude and the angle also from the components. But I would advise you to first draw the vector in terms of components and then find the angle using trigonometry. Let me now show you how addition of vectors becomes very, very easy in terms of its components. So let's start with two vectors, 4i cap plus 2j cap. Let's write this. Let's write down this vector here. It is 4i cap plus 2j cap. Now let's draw a second vector. That vector is going to be I cap plus 2j cap. So this is vector A and this is vector B. And let's say we want to add the two vectors. I want to know what A plus B looks like. Let me slide the second vector and move it here. The second vector is I plus 2j, so it's going to be that. Check it out. It has the same length and the same direction as B. And the vector sum of the two is going to be that vector. Let's call that vector C. Now let's look at C's components. C's components are going to be 4, which is the x component of A, plus 1, which is the x component of B. The x component of C is this, and the y component of C is that. And you can see immediately that if I drop this perpendicular here, that the x component of C, Cx, right, is the x component of A plus the x component of B, Ax plus Bx. And likewise, if I draw this line here, you can see this is the y component of A and this is the y component of B, and so the y component of C is Ay plus By. In other words, when I want to add the two vectors, simply add the x component separately. 4 plus 1, 5 I cap, plus 2, 4 j cap. That is my vector C. Check it out. 5 I cap plus 2, 4 j cap, and that is our vector C. So addition of vectors becomes extremely simple when you express the vectors in terms of its x and y components. When you do that, you add the x component separately, you add the y component separately, and it works out beautifully. Now you may want to try it out for cases where one of the components is negative. Shall we do that quickly? So I'm going to choose A to be 4i plus 2j. So that's 4i plus 2j. And let's call this A. And that is, I'll write it here, 4i plus 2j. That is equal to vector A. And vector B, which I'm going to now introduce, let's make it minus 2i plus j. Right? Watch how I do that. If I want to write down minus 2i plus j, starting from the tip of A, I go minus 2 units. So, like so from here, minus 2 units, and then plus 1 unit j, I end up with that vector. Correct? So let me get rid of the clutter. So minus 2i plus j is that vector, that is B. So this is A and that is B. The vector sum, which I'm going to draw in red color, is going to be that. C is equal to A plus B. Now take a look at C. C is going to be 2i plus 3j. 2i plus 3j. Can you see that? C is going to be, starting at the tail, 2i plus 3j. And check it out. 4 minus 2 is 2. 2 plus 1 is 3. So add the x component separately, add the y component separately to get the vector sum in terms of components. So addition of vectors, once you write them in terms of components, reduces to ordinary addition. Now you can see why they chose this symbol plus for vector addition also. And now the last thing in today's video, we're going to look at how to go from magnitude angle description of a vector to the component description of a vector. Supposing we are given a vector whose length is given as 6 units, and let us say it points at an angle theta, whatever the angle theta might be. It may be 30 degrees or 45 degrees or whatever. We'll call the angle theta, and the length of the vector, let us say, is 6 units long. If I want to write it in terms of its components, first thing I do is drop this so that I have a right angle triangle, and then you can see that the adjacent side for the angle theta is nothing but the x component of the vector. So this is Vx, and the opposite side is Vy, the y component of the vector. So this vector you can see is Vx I cap plus Vy j cap. And check it out, by trigonometry, adjacent side by hypotenuse is cos theta, hence Vx is 6 cos theta, and opposite side by hypotenuse is sin theta, and therefore Vy is 6 sin theta. So this vector can now be written in terms of its components: 6 cos theta I cap plus 6 sin theta j cap. So draw the vector, use trigonometry, and solve the problem. Some students make the mistake of memorizing that it's always cos theta for the x component and it's always sin theta for the y component. That would be wrong if I had given theta as not this angle but this angle. If I had given that as theta, then you can see this is 90 minus theta, and 6 cos 90 minus theta will become 6 sin theta. The x component will become sin theta. The y component will become 6 cos theta. So you got to be careful. My best advice to you is always draw a diagram. For every physics problem, draw a diagram. Okay? We'll stop the video here. We'll see you next time. Ciao.